Welcome back, ladies and gentlemen. I know I said I was just going to do this next time, but I needed to wait for the video to finish processing anyway, so I thought, you know what? Why don't I just film them both at the same time? This is page 40. It's not going to be very hard. At least I hope not. We'll find out. Maybe it's going to be an impossible task, but I'm hoping this is going to be pretty clear. Page 40 talks about the fact that we've already seen basic stoichiometry, turning, this into this, turning this into that, turning this into this into that, whatever. Converting between these, finding out how much of each I need to make things happen. But as we've discussed before when it came to talking about moles and grams, we have a fundamental problem that there is no device that you can grab and point at something to find out how many moles there are in it. We do have a device, however, to measure mass. So we need to be able to work stoichiometry with mass. Now, as it mentions here, the techniques are pretty straightforward. First, you balance the chemical equation. Okay, we've got our balanced chemical equation already. That part's easy. Second, we have to convert whatever gram amount we are given into moles. Step 3, we use stoichiometry to turn those moles of one thing into moles of another thing. And then step 4, we turn the moles of that final result back into grams. So it's kind of like, we're going up a ladder, across a catwalk, and down a ladder in order to get from one side to the other. Unfortunately, you can't go straight across because these chemical equations only work with moles. They don't work with grams directly. It's annoying. We saw the same thing when we were doing conversions of grams, moles, and particles and volume. But here it is again. Let's look at an example. It will really come together with an example. So the example here is if I have 4.04 grams of H2, how much NH3 will be produced? N2, it says, is in excess, meaning it never runs out. So what I'm kind of saying is that you can just ignore this one, and this is the only real thing. I'm saying if I've got X of this, 4.4, how much of this do I make? And how heavy is it? Right? Do I need a big container, a small container? What's going to happen? Okay, so when we set this up, it is still the same conversion matrix. It is still have, want, lose, gain. Nothing about that has changed. And we know how to do conversion. I mean, I hope so at this point. You guys have done so much at this point. So we set it up, and we're going to get 4.04 grams of H2. Now we're going to want moles of H2. Set it up. We're going to lose grams. We're going to gain moles. And now I got to remember what numbers to put here. I'm turning grams to moles. That means I need to use the molar mass, which means I need my periodic table of the elements. So I check my periodic table. Hydrogen is, of course, 1. But I'm talking about hydrogen gas. So that means it's going to be 2. 2.02 is 1 mole. So if I take 4.04 divided by 2.02, you're going to get 2 moles of H2. So now we have managed to turn this new problem into the problem we just did last video. It's now just 2 moles of H2. We know what to do with that. At least I hope so. So I'm going to put another color. Let's go with blue this time. And I've got 2 moles of H2, and I could start writing it fresh, but to be honest, I'm just going to build it right off of here. That's why I'm using another color. Colors can make things nice. I want to know moles of NH3 that we're going to make. So we set it up, and we're going to have moles of H2 on the bottom, moles of NH3 on the top, because we want to get rid of the H2 and we want to get the NH3. This is 2, this is 3, because there they are. So 2 times 2 is 4. 4 divided by 3 is not a nice number. So 1.33 moles of NH3, and we're done. We're not done. I'm sorry, I lied. The question asks you how many grams are you going to need. So we need to figure that out. Now, if we were taking a look at our notes, because I'm just breezing through this, my apologies if that lost anybody. So let me just recap. We balanced the chemical equation. Oh, right there, balance. That's already done. I had that to start with. Then I took the grams and I converted it into moles. That is step 1. Then step 2, in blue, I took the moles of my reactant, H2, use stoichiometry to convert it into moles of product. Okay, so that's step 2. Step 3 is now I take my moles of product and convert it into grams of product. Basically, how heavy is it? We'll do that one in red. And once again, I could just rewrite everything again, but I don't really need to and I don't really want to. I'm just going to use another color and keep going. Grams of NH3. Brackets equals. We're talking about moles at the bottom because we want to get rid of them, grams at the top because we want to get more of them. 1 mole of NH3 is how many grams? Okay, well, we'll have to figure that out. I mean, it's in the answer key, but I'm going to figure it out. So NH3 has got, of course, 1 N and 3 H's. N is 14.01, I think, and H is 1.01. Let me just double check the periodic table. Hey, 14.01. I had it right. Who knew? It's almost like I've done this for a while. So this is going to be multiplied by 3. So you're going to get 3.03, 14.01. So you're going to get 4.04567, 1. There it is. So that is what goes in here, 17.04. You can see all of the individual pieces that we've been learning this unit are building on each other. How we found the molar mass on page 5, I think that is, might have been 4. At the start of the unit, how we found molar mass, how we did conversions, now how we do stoichiometry. And you'll notice, again, in the middle here, this part here, right, if I were to cover up the rest of the board, this is what we did last video. This and this is what we did 2 videos ago. Well, more like 4. It's just conversions. So we've just bookended stoichiometry in the middle here with 2 conversions in order to make this whole thing work. All right, enough talking. I got to actually finish it. So I take my 1.33 and I multiply it by 17.04. And I'm going to get 22.72 grams. And that is not what I got. What happened here? Did I type something in wrong? Or did I just have a mistake in my answer key? Let's see. 1.33 times 17.03 equals. No, I'm getting 22. Must have a mistake in my answer key. Oh well. I'll fix that up. 2 mistakes. Man, I'm on a roll. So, there we go. That's how you do this. It's pretty straightforward. And as you kind of saw, we kind of were able to put it together all in one line. I mean, you could actually take it further. As it says at the bottom of the page, all of these steps could be combined entirely. Like, instead of writing the 2, I could have just written it, can I stand in the way, like this and like this, and just show you, here's my start, I do this conversion, then that conversion, and I get my final answer and call it a day. That's a lot more mathematics, though, and that's only something I recommend if you're feeling particularly comfortable. As it is, if you don't like the fact that I did this all in one line like this, and you would prefer to be like, okay, here's the first calculation, here's the second calculation, here's the third calculation, go right ahead. There's nothing wrong with that. I've done a lot of math, so sometimes I end up, doing a lot of math. But that's kind of it. That's what this is. You start with grams, you turn it into moles, then you do some stoichiometry to get it from one side of the equation to the other. Then you turn the new results into grams again. And with that, you guys are ready to do 41, 42, 43, 44, 45, 46, 47, and 48. I know, right? It seems like the shorter the videos get, the more pages you get to do. It's just the nature of the mathematics of this. A lot of practice. Anyway, I think I will leave it there. I might even merge these 2 videos together because they're so short, but maybe I'll keep them separate. That way you guys can have some smaller videos. But I'll see you guys next time.